चलिए बस स्टार्ट करें। अच्छा, so this one we have ये मई जून समर 20 तला ये यही करना है ना पेपर, ठीक है? कोई और करना है मुझे बता देना। वी डूइंग दिस पेपर टू, वी डूइंग दिस पेपर टू, और इसमें कि स्टार्टिंग with the first question. Starting with the first question, वो कह रहा है कि element group 13 क्या है, ठीक है? That's group 3. A sample of gallium is analyzed, or what is meant by the term relative atomic mass? Remember, relative atomic mass, the definition is कि when you talk about the relative atomic mass, it's the average mass of an atom of an element और ये average का word important है, ठीक है? It's the average mass of an atom of an element compared to 1/12 the mass of the carbon 12 isotope. ठीक है? Atomic mass unit इसका वो होता है, reference होता है. अच्छा, anyway, so remember it's the average mass of an atom, ठीक है? Then you have calculate the relative atomic mass of gallium in the sample. Give your answer to 4 significant figures. तो हम इसी के ऊपर working कर लेते हैं कि how do you find the AR? How do you find the average? It's basically percentage multiplied by the mass. इसके दो masses हैं. One of the isotope is 69, the other one is 71. So 69 would be multiplied by its percentage, which is 60.11 divided by 100, और फिर दूसरे को ऐड कर लो 71 into, so 71%, so that's sorry, not 71%, 71 into 39.89% over 100. ठीक है? If you try and do the calculation, क्या what is the value that you're getting?
69.7.
नहीं, उसने कोई decimal places का है, 4 significant figures कहा है उसने, 4 significant figures.
69.74.
69.774.
Yes, sir.
ठीक है? और मैंने वैल्यू सारी सही लिखी है, 39.89, 60.11, ठीक है? So it's coming out to be, so ठीक है, it's coming out to be 69.74. Complete a table which describes the gaseous atom of gallium. The gallium periodic table, I think the data booklet is here. So 1 second. So the periodic table, where's gallium? Gallium is यहाँ पे जो given है, that's 69.31 given है, ठीक है? तो we're going to take 31. तो ऊपर उसे 71 दिया बस. He's talking about a specific isotope, ठीक है? तो this is about a specific isotope of gallium, और इसमें कि nuclear number ये ऊपर वाला number होता है, that's always a whole number, ठीक है? Remember, nuclear number is the sum of protons plus neutrons, always a whole number. अगर वो mass की बात करता तो वो decibels में होती. अच्छा, the next one is total number of electrons in the lowest energy level. इसका क्या मतलब है? अच्छा, sorry, lowest energy level का मुझे अभी भी नहीं मतलब पता. Total number of electrons in the lowest energy level, वो first shell की बात कर रहा है, किसकी बात कर रहा है?
तो शायद वो S2 की बात कर रहे हैं.
हाँ, वो फिर 2 होंगे. So let's write 2, कोई इसको check भी कर ले, क्योंकि I mean that's probably the answer. वो 1s2 की बात कर रहा है, ठीक है? या first shell की बात कर रहा है. I said then you have type of orbital which contains the electron in the highest energy level. So without writing the electronic configuration, how would you know this?
It's 1.
Remember कि group 3 की जो electronic configuration होती है ना, that is end के अंदर ना S2 आता है फिर P1 आता है. ठीक है, मतलब remember this कि if you have a periodic table in front of you, ये जो if I write on this, group 1 would always be S1 right at the end. जो highest energy shell होगा outermost, this one would always be S2. इसका जो group 3 का outer shell होगा, that's going to be just a second, ये बंद करो. अच्छा, इसका जो outer shell होगा, that's going to be S2 and P1. This one is going to be S2, मतलब वो कोई number होगा, कोई shell number होगा, 4S2, 4P1, etc. So and so on. This one would be S2, P2, and so on. It continues till this one would be S2, P3, P4, P5, और फिर इनमें S2, P6 होगा. ठीक है. So since it's 13, so that's going to be P with one electron in it. The type of orbital, that's going to be P. अच्छा, उसके बाद the next part of the question. Okay, when gallium is heated in excess of chlorine, gallium trichloride is made. Draw the shape of gallium trichloride molecule. Remember, gallium is in group 3. So उसका मतलब है it only has 3 electrons. And if it bonds with 3 Cls, so all 3 electrons are getting used up. तो इसका मतलब there are no lone pairs. ठीक है, all 3 electrons are getting used up. So this is exactly what the shape of the molecule is going to look like. This is called trigonal planar. Well, it looks like a fan. And all the angles are going to be 120 degrees because it has no lone pairs. अच्छा, फिर next is कि gallium oxide and aluminum oxide react in the same way with HCl and with NaOH. तो वो gallium oxide की equation मांग रहा है. Basically he's asking for the equations for aluminum oxide, जो कि आप inorganic chemistry में पढ़ चुके हो. तो think of gallium oxide as aluminum oxide. तो HCl के साथ reaction होगा तो क्या बनेगा? AlCl3, which in this case would be GaCl3 plus water. And you can balance this to 6 HCl's ho jayenge, and that would give you 3 water molecules. So that's it. Next one is suggest an equation for the reaction of gallium oxide, again aluminum oxide, Ga2O3 plus NaOH. Since it's amphoteric, it would react with NaOH and it would form an aluminate, which is going to be NaAl, जो कि GaOH4, or it could be GaO2 plus H2O. ठीक है, remember these two reactions, but for aluminum this would have been NaAlOH4 or NaAlO2. ठीक है, so I mean both of them are pretty much the same thing. तो आपने you just have to change Al to Ga. Now the next question is that there's nitric acid and it can be made in this 3-stage process. Or first part, stage 1, ammonia is oxidized to oxide by oxygen from the air. Reaction लिख लेते हैं कि ammonia is getting oxidized, so it's reacting with oxygen to form nitrogen monoxide, so NO, and water is being produced. So this is what's happening. Okay, this reaction is carried out at 10 to 13 atmospheres of pressure, etc. Everything is given. Then the second stage, which is this one, okay, the NO is reacted to form NO2, and then you turn NO2 into nitric acid. Writing the equation to show the reaction during stage 1, we've already done that. The only thing you have to be very careful about this reaction is, बल्कि इसको वैसे ही balance कर लो. How would you balance this equation? Okay, NH3 plus O2 and forms NO and H2O. H को balance कर लो तो there's going to be 2 and there's going to be 3 H's. So H is balanced. तो उसके हिसाब से फिर आप N को balance कर लो. There's 2N, so there's going to be 2 NO. And then you can balance the oxygens. On the right side, the number of oxygens are 2 plus 3, that's 5. तो यहाँ पे oxygens कितने होंगे? That's going to be 5 by, it's going to be 5 by 2. ठीक है, वो इस साइड पे oxygens होंगे. और उसको अगर whole numbers में convert करना है, multiply everything by 2, which you don't really have to. Draw the dot and cross diagram to show the arrangement of outer electrons in a molecule of ammonia. तो वो तो कोई इतना बड़ा मसला नहीं है. Okay, there's going to be N, there's going to be H atoms attached to it. single bonds everywhere, N in the middle, and that would leave you with a lone pair. Achha, in the boxes, give the oxidation number of nitrogen in the nitrogen containing species for the reaction in stage 3. So this is clearly NO2, that's plus 4. This is अगर यहाँ पे N is plus 5, ठीक है, you can measure it. Okay, O is minus 2, so that's minus 6. H is plus 1, so this would be plus 5. And N over here is plus 2. So that's the reaction over here. फिर अगला part है कि explain why the reaction in stage 3 is described as a disproportionation reaction. Include reference to transfer of electrons in your answer. So why is this a disproportionation reaction? Because the same element, ठीक है, disproportionation is the same element is getting oxidized and reduced. So the same element is getting oxidized and reduced in the reaction. So that's known as disproportionation. और इसमें उसने कहा include reference to transfer of electrons. So वो लिख दो oxidized को loses electrons, reduced gains electrons. ठीक है, बस यही ऐड करना होगा. That's pretty much it. I said the release of nitrogen monoxide in the atmosphere causes atmospheric pollution, and Stan explained the effect of nitrogen monoxide. कि क्या effect होगा nitrogen monoxide का? क्या चीज cause करती है? Or moist air. So it's going to produce
acid.
और उसका effect कोई भी उसने किस पे effect पूछा हुआ है? बस effect पूछ लो कि वो causes acidic soil. Water bodies become acidic, limestone buildings corrode, and effects on human health के कि आपका जो skin and eye irritation etc. ठीक है, those things are going to happen. Then you have nitric acid made in stage 3 can be reacted with ammonia to form ammonium nitrate. Calculate the volume of, so it's a moles question. वो कह रहे calculate the volume of nitrogen dioxide measured at room temperature and pressure required. तो NO2 पता करना है. ठीक है, this is what you have to calculate. और उसने कहा कि nitric acid और दिया हुआ क्या है 40 tons of ammonium nitrate. So you're given 40 tons of ammonium nitrate. This is the ammonium nitrate that we have to produce. तो इसके moles निकालो. उसने kgs भी दिया हुआ है. You can so 40 tons is 40 times 10 power 3 kg, and each kg has 10 power 3 grams. It's 40 times 10 power 6 grams. So divide that by the MR of ammonium nitrate. The MR would be, what's NO3? NO3 I think is 62 plus कितना होगा 14. So that's probably 80. You confirm कर लो MR. So that's the moles of ammonium nitrate. कोई मुझे इसकी value बता दे. What's the value that we are getting? कितने moles आ रहे हैं? And is the MR
5 into 10 to the power 5 moles.
अच्छा 5
into 10
times
to the power 5.
अच्छा 10 power 5 moles. ठीक है. तो ये आपके moles आ रहे हैं. और फिर उसको बैक ट्रेस करो कि इतने मोल्स होंगे तो NH3 और HNO3. ठीक है, let's talk about HNO3. HNO3 moles would be exactly the same as well. 5 times 10 power 5 moles, right? And अच्छा 5 times 10 power 5 moles और वो पिछले reaction के अंदर produce हुए थे. So those 5 times 10 power 5 moles use ratios So the amount of NO2 moles that would be needed to produce that much would be 2:3. So it's probably going to be 7.5 times 10 power 5 moles. Okay, so this much nitric acid, 1:1, this much nitric acid was needed. And this nitric acid was produced in the previous reaction. And if it was produced in the previous reaction, so that much NO2 would be needed. तो NO2 के moles पता लग गए. Make sure paper के अंदर ना ये neatly करना, ठीक है? Make sure कि you write के this is moles of NH4NO3. Show the working. फिर ratio लगा के show them कि इनका ये ratio है, ठीक है? And
सर
7.5
HNO3 के मोल्स कहाँ से हैं हमारे पास?
इधर से है ना, क्योंकि NH4NO3 के आए थे ना.
तो अच्छा
तो
देर
एक
इन 1:1, ठीक है सही है सर.
और ये HNO3 पिछले रिएक्शन में प्रोड्यूस हुआ है ना, तो मतलब all these moles where they coming from the previous reaction, right? तो अब आखिरी पार्ट क्या करना है, कैलकुलेट क्या करना था, वॉल्यूम ऑफ नाइट्रोजन डाइऑक्साइड, हाउ डू यू प्रोड्यूस एंड इज इट एट रूम टेम्परेचर, ये ख्याल रखना, ठीक है? एएस में ऑलवेज रिमेंबर कि वो इज ही टॉकिंग अबाउट रूम टेम्परेचर और इज ही नॉट टॉकिंग अबाउट रूम टेम्परेचर, वरना फिर वो पीवी इक्वल एनआरटी आ जाता है बीच में. सो सिंस इट्स रूम टेम्परेचर, द वॉल्यूम इज मोल्स 7.5 times 10⁵ multiplied by 24 dm cube. So what's the answer that we are getting?
1.8 into 10 to the power
10 इस बार कितना है?
7.
7 dm cube. So that's your answer, ठीक है? Just make sure कि statements लिखना, छोटी मोटी statements लिखना, moles मतलब moles of nitric acid, इस तरह करके working ना show करना, ये तो बहुत गलत तरीके से आंसर किया है. Just make sure कि when you're writing this, especially in your paper 2s, moles of nitric acid ratio लगा लो कि nitric acid HNO3 ratio show करो, फिर बताओ कि इसके इतने moles हैं, इसके इतने, और फिर उनका ratio लगाओ, उसकी working show करो. As I state one use of ammonium nitrate, where are ammonium salts used? That's ठीक है, fertilizers, NPK, ठीक है, these salts.
Sir, apart from fertilizers, what is ammonium nitrate else used for?
What is?
मतलब ammonium nitrate की uses apart from fertilizers.
नहीं, उसे क्या one use बताओ ना. main जो use of fertilizer है, उसके अलावा कम ही, मतलब fertilizer is a massive use, ठीक है? उसके अलावा तो बहुत ही कम use है इसका. मतलब उसके अलावा बहुत सारे uses होंगे, बहुत जगहों पे use होता होगा, ठीक है? But they're not important. Ammonium nitrate का तो probably there's only जो major use है, that's just one. वरना वहाँ पे I mean it's obviously used in a lot of reactions, industrial reactions, लेकिन वहाँ पे it's not the main thing, ठीक है? मतलब वो बस एक it's being used as a reactant. I said next is that you have sucrose reacts with water to form glucose and fructose in reaction A. So some sugar is over here. Suggest a name for this type of reaction. What happens when water breaks down a molecule?
Hydrolysis.
Okay, that's hydrolysis. As a next, explain in detail why glucose and fructose are a pair of structural isomers. Your answer should refer specifically to these molecules. So if you look at these molecules, उसने खुद ही कहा है they're structural isomers. So you're going to write that they have the same molecular formula, but you don't even have to count them because he's already told you that they are. So they have the same molecular formula, but different structures or different structural formulas. That's basically what an isomer, that's what an isomer is by definition. I say उसने थोड़ा डिटेल भी मांगी है, पता नहीं उसमें what you can do is you can count the MR. वरना probably just 2 marks, that should be sufficient. A reaction A occurs faster in the presence of an enzyme. This is reaction B. किस reaction की बात कर रहे हैं? The same reaction. I mean, there's only one reaction. तो वो कह रहे हैं there's another reaction which is B, and that happens faster in the presence of an enzyme. तो predict a value for the activation energy of reaction A. तो B की ये है, तो A की जो वैल्यू होगी that would be greater than B. मतलब उसको let's say predict करना है ना, तो कोई भी predict कर लेते हैं as long as it's greater, क्योंकि reaction A would be slower. Reaction A was the one जो ऊपर given था, that was without enzyme. So then the enthalpy change for reaction A is minus 14. Predict the enthalpy change. Remember, the enthalpy change is not affected. It's going to remain exactly the same. Catalyst would not alter the enthalpy change. It would just make the reaction easier. It would reduce the activation energy. Or please sketch a labeled energy level diagram for reaction B. Use the relevant values from C1 and C2. So reaction B की बात हो रही है. So if you look over here, reaction B और A की enthalpy change तो same है. तो इसका मतलब है it's an exothermic reaction minus 14. In an exothermic reaction, the reactants are going to be at a higher energy and the products are going to be at a lower energy. So this is the activation energy. This is minus 14. That's delta H. इसको correctly label कर लेना हर चीज को kilojoules per mole. This is the activation energy that was given as 29, if I remember correctly. EA was given as 29. Kilojoules. It was given as 29 kilojoules per mole. और ये आपके products हैं. Instead of writing, I think reactants and products should be sufficient. लेकिन what you can, just to be on the safe side, what you can do is you can write the reactants. You can write the name of the reactants जो ऊपर थे. कि sucrose plus water, that's your reactant, and the other one is glucose and fructose. So you can write the name of the products in this. Okay, that's pretty much it. Delta H label करना and you have to write EA. Next one is 1 gram of sucrose is completely combusted. The heat energy produced is used to increase the temperature of water inside a calorimeter from 25. So these data can be used to calculate the enthalpy change of combustion of sucrose. Explain what is meant by the term enthalpy change of combustion. So it's the energy released. You can remember it's always exothermic. When how much combustion happens when 1 mole of sucrose combusts in excess oxygen. And since he's not talking about standard, so you don't have to write the last statement, which is K. They are measured under standard conditions. Because he hasn't mentioned standard enthalpy change. So he's probably not doing standard enthalpy change over here. So you don't have to write the entire description. Okay, measured under standard conditions, and everything being in the standard states, because he's not using the word standard over here. As you use the data booklet to calculate the enthalpy change in kilojoules for the combustion of sucrose, so what you can do is water is being heated. So you're going to use MC delta T. पहले तो water is 250 grams. Remember, we're just calculating when you burn sucrose, so how much heat went into water. So the 250 grams water, the specific heat capacity is given in the data booklet as 4.18. You can open the data booklet and see. And delta T is 25 and 40.7. That's, I think, 50.7. This is around 15.7. And the value is going to be negative. Remember, if temperature rises, make sure you think of this yourself. It's going to be exothermic because temperature is increasing. So how much energy change is this? What are we getting for this?
16 kilojoules.
The 16? Yeah, exactly value hogi.
16406 joule.
I said 16406 joules. And so that's it, okay? And what you can do is you can round this off to three significant figures, because all your values are accurate up to three significant figures. 1 gram temperature, okay? So your answer cannot be more accurate than that. So you can round it off to uh, 16.4 kilojoules. अच्छा, anyways, show your working. We've done that. और फिर उसके बाद है कि अच्छा, that's not it, क्योंकि enthalpy change is for 1 mole. So we have to figure out कि how much moles is this. So this is 1 gram of sucrose. So how many moles is this? That's 1 divided by the mR of sucrose, which is 12 into 12 plus 22 hydrogens plus 16 into 11. So that's mass divided by mR. So these many moles, they produce 16.4 kilojoules of energy, right? 1 gram. So how much would 1 mole produce? So 1 mole is going to produce how much? You can use ratios. So यहाँ पे x would come out to be, if you it would come out to be 16.4 into 1, and then divided by this whole thing. Okay, so if it's being divided, so this would actually get multiplied. So it's going to be 12 into 12 plus 22 hydrogens plus 16 into 11. Can somebody tell me what the value is? And what is the answer that we're getting? किसी ने किया कैलकुलेट अभी तक? Zaeb, Ibrar, anyone?
So why did you multiply 16.4 with the moles?
नहीं, 16.4 मतलब ये ना कि these many moles, they produce this much energy, right? मतलब वो 1 gram था ना, उसने क्वेश्चन में कहा हुआ था कि 1 gram of sucrose था, तो वाटर ये था, ठीक है? तो ये क्लियर है, इतने मोल्स इतनी एनर्जी प्रोड्यूस कर रहे हैं. तो we were being asked to find the enthalpy change for 1 mole. तो रेशियो लगा 1 mole कितनी प्रोड्यूस करेंगे. So 1 mole would produce x. How would you find the value of x cross multiply? तो
So,
x क्या होगा?
so आपने वहाँ उसको the 16.4 will be divided by the moles. That is when
नहीं
you multiply it.
नहीं, डिवाइडेड बाय, हाँ डिवाइडेड बाय होगा ना, लेकिन वो ये 1 over ये है ना, तो जब 1 over
ठीक है सर.
इससे डिवाइड होगा तो वो फिर मल्टीप्लाई हो जाएगा एक्चुअली.
56.16.
कितना?
56.16.
56.
56.16.
जब माइनस होगा, ठीक है, ये रिमेंबर कि ये इधर हमने माइनस साइन भूल गए थे. दिस इज ऑल माइनस, ठीक है. तो -56
16.
और 16 यार. अच्छा, इसमें मेक श्योर यू डोंट मेक द मिस्टेक कि व्हेन यू वर डूइंग द कैलकुलेशन, तो डोंट टेक 16.4, ठीक है. मेक श्योर, although when you're writing it down, write 16.4, especially when you have a very long decimal number that's coming in. जैसा for example यहाँ पे 16406 कुछ आ रहा था, ठीक है. So when you write it down, you write it to three significant figures, क्योंकि your answer cannot be more accurate than the values you're taking to calculate it. 25.0 इसका मतलब है कि 25.0 के बाद you don't know what the decimal is. So you can't be more accurate than the values that you're using. But the thing is, कैलकुलेटर के ऊपर don't round it off, क्योंकि हर स्टेप में अगर राउंड करोगे ना तो एंड में एरर बढ़ता जाएगा. That's a rounding error. So when you're doing the calculation, don't take 16.4. Take the whole number 16406 करके ना जो भी number था. That's the one that you're going to take. So your answer is going to come out to be more accurate. But if you are taken 16.4, then the accuracy of the answer would slightly be different. The end values might be slightly different. As the next is there's an unlabeled. Okay, next is there's an unlabeled bottle that contains straight chain halogenoalkanes. So it's a remember straight chain, so no branching. And the molecular formula of Q is given C5H11X, where X is a halogen and it could be chlorine, bromine, or iodine. So there are 5 carbon atoms in a line. What we don't know is, okay, where is the halogen? Is it on the first carbon atom, the second, or the third? But there's one halogen. Okay, a test is carried out to identify the halogen present. It's heated with NaOH and warmed, and dilute nitric acid is then added, followed by silver nitrate, and a cream precipitate is formed. Now, this cream precipitate is a test for Br-1. That means bromine is present, because a yellow precipitate with silver nitrate is obtained by iodine, and a white precipitate is obtained by chlorine. So write an ionic equation to describe the formation of the cream precipitate. So what happens is that Ag+1 in silver nitrate, they would combine with the Br-1 that are coming from the halogenoalkane, and they form an insoluble precipitate because AgBr is insoluble. So they form this insoluble cream precipitate of AgBr solid. Pising describe a further test to confirm the identity of X. So what could be a further test? Halides का test, remember? Huh?
Bromination.
No. It's a test for halides. Halide का complete test क्या होता है? मतलब
Adding
एक तो
excess ammonia.
ठीक है, you're going to add ammonia. ठीक है, you're going to add ammonia. Remember कि that all of them they form a precipitate: white precipitate, cream precipitate, and yellow precipitate. But in ammonia, iodide, the precipitate of AgI, that's not soluble. The precipitate of AgCl is always soluble. The precipitate of AgBr is only soluble in concentrated ammonia. Okay, so that it dissolves in concentrated ammonia. So the further test is you're going to add aqueous ammonia, and you're going to add concentrated ammonia. And the expected result is that precipitate dissolves. Next one is the reaction of Q with NaOH tends to proceed via an Sn2 mechanism. Now, Sn2 mechanisms were for primary. They were for primary halogenoalkanes. So suggest the structural formula. So the structural formula is going to be it's going to be 5 carbon atoms, and the Br is going to be at the end. So this is CH3. You have CH2. I'm going to draw the mechanism as well. Another CH2. So this carbon over here has a partial positive charge. Br has a partial negative charge. The positive charge is very strong because it's not surrounded by carbon chains. There's only one carbon chain, so there's not a lot of electron donating effect. So the positive charge is very strong, which is why the Br-1 would not be able to leave. And because the positive charge is very strong, it will attract nucleophiles directly. And the nucleophiles are going to come in, and then they are going to push the Br away. Okay, so there's going to be a transition state where the OH and the Br would be partially bonded to carbon, and then the Br would eventually leave. So explain why the reaction tends to proceed via the Sn2 mechanism. So that's what he's asking now. So what you're going to write is you're going to talk about the carbocation, that a primary carbocation is very unstable, as it has fewer electron donating alkyl chains. Not alkyl donating, electron donating. I'm going to explain this just a second. So it has fewer electron donating alkyl chains. Um, so it has greater charge density. So what all of this means is, why is the Br not leaving? I mean, that's the difference. In SN1, the Br leaves on its own. So why is the Br not leaving? Let's assume that the Br leaves on its own before the OH arrives. So the Br minus 1 leaves and this carbocation is formed. The reason it can't proceed by an SN1 mechanism, which is this one is the SN1 mechanism where the Br minus 1 leaves, and then later on the OH minus 1 comes in and bonds with the carbocation, right? The reason this cannot happen is that the positive charge over here is kind of large. And why is it large? Because it's surrounded by hydrogen atoms, and there are fewer alkyl chains. Alkyl chains have an electron donating effect, but there's only one of them. So the positive charge is still going to be very strongly positive. So it will pull the Br minus 1 back. It won't allow it to leave until the OH minus 1 comes in. So uh, that's the reason. So you have fewer electron donating alkyl chains. Okay, is this clear? Mohammed, is this clear? ठीक है Zahib, clear?
Yes, sir.
So then the next part is two different halogenoalkanes P and R both have the molecular formula C4H9Cl are separately dissolved in ethanol and heated under reflux with NaOH. So remember, when ethanolic NaOH is used, there's an elimination reaction, which means that alkenes would be formed. The major organic product of these reactions is methyl propene. Name the type of reaction. That's an elimination reaction. Let me draw methyl propene. Methyl propene is propene with a methyl group over here. And there's a double bond. And this will have three H's. All of this would be hydrogens. Now, before elimination happened, this was a halogenoalkane, which means that the double bond wasn't there. And instead of the double bond, there were probably an H and a Cl attached over here. So there are two possibilities. One is that the H and Cl are attached in this manner, and because both of them are forming the same alkene. The other possibility is that the H and Cl positions are switched. So in an elimination reaction, this is what usually happens, that you have Cl getting removed from one atom and you have H getting removed from the other atom. So the two molecules, because they result in the same molecule, the same alkene. So the difference would be that the Cl would be at the end and the Cl would be in the middle. So write an equation to show the using molecular formula. So you have to be very specific about molecular formula. So what's the molecular formula? This is C4H9Cl. Elimination happens, HCl is removed, and what's left is C4H8. So that is what's left. And you have to draw the skeletal formula of methyl propene. So that's 3 carbon atoms. And on the middle one, there's a carbon atom. That's 1 carbon atom. Give the name of P and R. So how would you name P and R? This one would be, ignore. Let's assume that the H and Cl are still present. So this is propane. 3 carbon atoms in a line. So that's propane. And you have a branch of methyl. And you have a branch of chlorine. So that's and the chlorine is attached on the first one, so that's 1 chloro and 2 methyl. Because it's let me highlight this. So it's 3 carbon atoms with a chlorine at the end. So that's propane with 1 chloropropane, and there's a methyl on the second one. The other one would be that the Cl position would be switched. So it's going to be 2 chloro. The methyl is still at the same position. So that's the name of both of the molecules. Okay, is this clear? Tala clear? Zaid clear?
Yes, yes.
So then you have number 5. Number 5 is you have a reaction that's going on, and now you have question number 5. So the reaction sequence shows how ethene can be converted into other organic molecules. So a whole reaction sequence is given. So what is asked? What is asked is 1 and 6. Name them and name the reagents and conditions. So and 2 as well. So 1, 2, and 6. Let's go for 1. What is reaction number 1? That's an electrophilic addition reaction. Okay, it's an alkene जिसके अंदर ना water is getting added. It's known as hydration, but you're not going to call it hydration. It's okay, the double bond would break. जब वो type कहता है, you have to give the type. You have to give the mechanism of the reaction. So H and OH will get added. So this one is and you have to give the condition as well. So it's 300 degrees centigrade. You add water to it, which is in the form of steam. You add phosphoric acid catalyst as well, uh, and there's 60 atmosphere pressure. And this one is electrophilic addition. As a second one, guy, he's not asking for the name, although that's kind of easy because it's an alcohol, primary alcohol turning into an aldehyde. So this is oxidation that's happening. And you have to stop at the aldehyde. So for the second, the conditions would be it's going to be K2Cr2O7 and reflux, not reflux. K2Cr2O7 acidified and uh, distillation. Okay, that's you would have to immediately distill it, not reflux it. Okay, you're going to warm it. Because otherwise you have to remove the aldehyde as soon as it is produced. Because aldehydes they don't form hydrogen bonds, so they can easily evaporate. Uh, because if you don't do that, they would turn into carboxylic acids. अच्छा फिर sixth it's this one. It's Cl getting substituted by this is nucleophilic substitution. That's NH3 ethanolic and reflux or heat with reflux. As a pair, complete the table to give. So we're done with this. Then he's saying that in reaction 3, now this is nucleophilic addition, and he's asking for you to include all the relevant charges, etc. So the carbon over here is partial positive. There's a double bond O, so oxygen is partial negative. The Cn, the lone pairs on C are going to be attracted to this carbon, and the electrons in the double bond are going to get repelled. So this is what's happening. And in the next step, the oxygen electrons get repelled. The Cn bonds with it. So the Cn comes and bonds with the carbon atom, and the oxygen electrons they get repelled. So they're going to attract the H that is positive. and the electrons over here, they will be repelled. So end result is that there would be Cn minus 1 formed again. So that's the reaction condition. That's the reaction mechanism of a nucleophilic addition reaction. Okay, that's something that you have to remember. And name the functional group present in the product of reaction number 3. So you have to name the functional group. So it's a Cn and there's an OH as well. So there are two functional groups present. It's together it's known as a cyanohydrin. But since you have to name the independent functional group, so there's a nitrile and there's a alcohol, specifically a secondary alcohol. Because remember, the OH is attached to a carbon atom that's already attached to a bunch of carbon atoms. Okay, so that's a secondary alcohol. Draw the structure of the organic molecule W formed in reaction number 4. So what's reaction number 4? So you have to find, so heat with dilute acid. Remember that nitriles, they turn into carboxylic acids. So it's 1, 2, 3 carbon atoms. So what would happen is 1, 2, 3 carbon atoms. The third one would turn into a carboxylic acid. So this third one would turn into a carboxylic acid. This would be OH. And this would be CH3. And this would be H. So remember, nitriles get hydrolyzed. The N breaks away, turns into NH4 plus 1. Or jo baki hai na, that turns into that turns into a carboxylic acid. And the hydrolysis can happen with acid as well as an alkali. So that's the last one. And that's it. The paper is finished. Let's do another paper next time. Or
Okay, sir. Allah Hafiz.
specific paper.
I have a question.
Yes.
Like if we use an alkene, like actually a base like sodium hydroxide, won't the sodium hydroxide react with the carboxylic acid again?
हम उसके अंदर मतलब इसके अंदर alkaline hydrolysis की बात कर रहे हो ना?
Yes.
I mean the last one, right? This one, na?
Yes.
तो उसके अंदर
Yes.
हमेशा always remember whenever a carboxylic acid is formed and the conditions are alkaline, you're not going to get a carboxylic acid. Instead, it would form a salt. Like if the alkali is NaOH, it would form a salt of it would form a sodium salt. ठीक है? Always remember that. चलिए ठीक है. और अगर questions वगैरह, problems वगैरह, you can send all the problems. We can discuss those in class as well.
Okay, sir.
Allah Hafiz.